Hi everyone. So this is the lesson on today for transformations. It's Unit 1D6. So we're just going to start off by linking you back to what you did in grade 11 and even grade 10 with transformations. So the first thing that you have to notice is for any function, and in grade 10 you did quadratics, in grade 11 you did cubics, and I think rational functions too. I think the square root of x function, right, as well. So, but for any function, now this year we're going to broaden it out to any function. So, any function f, doesn't matter what it is, you would have a, which is the coefficient in front. We'll get to what those mean in a second. F is just the function. So, times k bracket x minus d plus c. And I know there's different textbooks that use different letters. When you're in grade 10, you use H and K for these two. I believe the grade 11 textbook last year used D and C. It doesn't matter what you use. P and Q. Sometimes it flips the D and the C. It doesn't really matter. It's where the letters are, not what they are, that matter. For a power function, which is where we started our unit here. So for any power function of degree n, you would have a. I'm not going to have f because the function is x to the power of n. So times k bracket x minus d power of n, so there's the power function, plus c. So the f that is any function is to the power of n, and the brackets here from there to there, that's inside the function, which in this case is inside the power function, which is to the power of n. Same with here, all this stuff here, k times x minus d in brackets, inside the function f, and that can change. It can be anything you want. Okay, and we're not doing this right now, but if you had square root of x function, it would be so this is an aside. If you had a square root of x function, it would be a times the square root of k bracket x minus d, and then close the function plus c. So a and c are outside the function. A and c are outside the function, and c are outside the function, k and d are inside the function. Okay, that's an aside, you don't need to know that. But just to link it back to other functions. So whatever, if it was, well, I know I'm getting off on a tangent here, but I think this is helpful. If it was sinusoidal, it would be a, and then the function is now sine. Inside of sine, you've got k, x minus d. Close that, so close the sign, you're no longer in sine, and plus c. So k and d are inside the function, a and c are outside, same deal. I got on a tangent there. You'd think on a video I'd be able to not be on a tangent, but I couldn't. So let's just quickly go through these. None of these should be a shock. A, vertical stretch or compression. Okay, so if it's a vertical stretch, a is going to be greater than 1 or less than -1, one or the other. If it's a compression, a is going to be between -1 and 1, but a cannot be equal to 0. If a is equal to 0, if you look at this, a times all that would just go to 0 and just have y equals c, so that's not that interesting, so it won't be 0. The other thing that a tells you, it's a reflection in the x-axis, also called a vertical reflection because it flips vertically. So not a shock. That's the same as what you did in grade 11 and even grade 10. K you wouldn't have done in grade 10, but you definitely did in grade 11. So same idea. So except now it's horizontal. So horizontal compression or stretch. I intentionally did these backwards. Not backwards, but reverse of each other. So if it's a horizontal compression, k is going to be bigger than 1, or k is going to be less than -1, because they're opposites. Meaning if a is 2, it's going to be a stretch vertically, but if k was 2, it's a compression by a factor of 2, so horizontally. And then for a stretch, it's going to be between -1 and 1, and k cannot be 0, for the same reason that a can't be 0. Okay, it also tells you whether it's a reflection in the y-axis. y-axis, which is also called a horizontal inflection. So it's going to flip it this way. Oh, you can't see what my hands are doing, but it's going to flip it this way, so it's going to... That's my function, it's going to flip it that way. That didn't work, but... Anyway, so it reflects it horizontally. I think you would have seen this before anyways. D is a horizontal translation. And it's D units. So D is positive, it's to the right. If D is negative, it's to the left. Be careful, it's inside the brackets. This minus sign here flips it, so if it says D plus 3, that's really to the left 3. It's always the opposite. C would be a vertical. We'll see that in a second. So C would be a vertical translation. C units. And if C is positive, it's going to be up. If C is negative, it's going to be down. So if C is greater than 0, it's positive, so it's going to go up. If C is less than 0, it's negative, it's going to go down. Okay. So let's work through an example. None of this should be a huge shock to you. I think it may have been a while since you've done it since grade 11, but it's exactly the same as grade 11. So let's do an example here. So we've got a function y equals 3 bracket 2 bracket x minus 3 close bracket to the power 4, so it's a power function plus 1. So on our power function, we're going to state the transformations, we're going to state the domain, range, and the equation of the axis of symmetry, and what points are going to correspond to these. So this might be new, although I think you would have done it last year. So let's start by stating the transformations on the graph. So for part A, state the transformations. So A is 3. And if A is 3, that tells me it's a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. Okay. So it's going to stretch it vertically. It's going to stretch it like this. K is 2. So that's actually going to be a horizontal compression. Horizontal compression by a factor of, I know there's different ways to do this with different books. I see it as a factor of 1/2 because you're multiplying it by a half. Some people would say by a factor of 2. I think it's a factor of a half. I think it's always 1 over k. That's my take on it. I'm not sure what you did in grade 11. It's not super consistent anywhere, but I always say 1 over k for that, because I always think of factor when you're multiplying with factor. Next is the d value. So d, in this case, it says x minus 3, but if you look up here, it's x minus d, so the d would still be positive 3. So d is positive 3. And if it's positive 3, it's going to move to the right. So right 3 units. And then the last part is c. C is positive 1, so that tells me it's translated up 1 unit. Okay, none of that should be a shock. That should be pretty consistent with last year. The only difference is it's a 4, which we haven't done, but that's okay. Part B, we'll say the domain and range. So since it's a power function, and it's the power of 4, there's nothing it can't be. So x is just an element of the reals, but I'm going to use interval notation. So x is an interval. It's an element of negative infinity to positive infinity. The range, a little trickier for the range. This is the power of 4. So you think of your end behavior here, it's the power of 4. The leading coefficient is positive. The rest of this junk really doesn't matter. It's going to have end behavior here to here, like that. So if it's going up, that means that there's going to be a minimum. And the minimum point is actually going to be this positive 1. So that's going to tell us where the minimum is. So it's going to come down like this. That's a terrible graph, but that's kind of what we're looking at. So if the minimum point is 1, then it's going to be y is an element of 1 to infinity. And the only question you need to ask yourself is whether I should use a round bracket or but the round brackets are always on infinity. But should I use a round bracket here or a square bracket here? So you should ask yourself, can it equal 1? And the answer is yes, because the minimum value is going to be 1. So I should be using a square bracket here. So that's the interval distribution there. Square bracket 1, comma 2 infinity. So that means y is an element of 1 to infinity, meaning it's going to go from 1 to infinity. It doesn't tell you the order, it just says the lowest it's going to be is 1, and then it's going to go up to infinity. And then for the axis of symmetry, very similar to what you did in grade 10 with parabolas. That's why I chose the power of 4. So the axis of symmetry here is going to be x equals, and then you just look at the horizontal shift or the horizontal translation. So let's move 3 units to the right. So 3 units to the right from the origin, move it over to x equals 3. So that's the axis of symmetry, x equals 3. I encourage you to graph this on decimals. Check it out. Make sure, we can't even see what I'm writing. Graph it on decimals. Make sure it's right. Just going to put a line here, split it up. And then for part C, what points correspond to this? So instead of doing it on a graph, using points is a great way to do it. So it really hammers in what you're doing to the individual points. So this is the base function. I'm just going to call this f of x. Doesn't label it, but I'm going to. So set bracket, -1 to 1, 0, 0, 2, 16, and 4, 64. So if I'm going to take these points and I'm going to do these things to them. So I go in the exact same order you would when you graph it. So just go A, K, D, and C, just in the same order I did here, just left to right order. It's easier to do the stretches and compressions first. Doesn't mean you can't do them after you do the translations, but it's much easier to do them first. You do some thinking, you got to take into account how much you've shifted it beforehand. So let's just go do the stretches and compressions first. So vertical stretch by a factor of 3. So you have to ask yourself, does that affect x coordinates or y coordinates? And if it's a vertical stretch, so it's this way, that's going to affect y coordinates. So what I'm going to do is, it's by a factor of 3, I'm going to multiply all the y coordinates by 3. So this is going to be -1 and 1, or -1, 3. 0 times 3 is still 0, so 0, 0. 16 times 3, I think, is 48. So 2 and 48. And 4 and 64. 64 times 3 is 192. Okay. And when I go to label what this is here, I put in a equals 3. So if I look up here to the top, can't see where I'm pointing, but if I look at the top, A is in front of the F, so I'm going to have 3f at x. So I go to write this, I'm going to have 3f at x. Okay, now I'm going to do k. So set bracket. So this is a horizontal compression by a factor of a half. So what that means is I'm going to multiply all the x coordinates by a half. If you were doing it by a factor of 2, you'd have to divide. That's why I do it. That's 1 over k. So this would be 1/2 times -1 is -1/2. And that only affects, oh, I didn't even point that out. Horizontal compression is this way, horizontally, so that's going to affect x coordinates. So that's why I'm dividing all the x's by half, or multiplying them by half. 0 times a half is 0, so I'm not touching the y coordinates here. Half times 2 is 1, 1 and 48. Half times 4 is 2, 2 and 192. Close the set bracket. When I go to label it, if you look at the top, k is inside of f but in front of x, so it's going to be 3f at 2x. That's what that looks like. So the next step would be write 3 units. So would left and right, would that affect x's and y's? Well, left and right moves this way, left and right, so that's going to be x coordinates. And it's going 3 to the right, so I'm going to add 3 to each x coordinate. This is going to be set bracket. -1/2 plus 3 is 2.5, which is 5/2. So I don't do anything to the y coordinates. So add 3, so it'll be 3 and 0. 4 and 48. 5 and 192. So all I've done is I've added 3 to each of the x coordinates. The horizontal translation does nothing to the y coordinates, it only affects x's, so I'm only affecting the x coordinates. So this would become 3f at 2 bracket x minus 3. Snookered myself here. That line. Squished myself. So that's what that's going to look like. And then just to make sure I don't run out of space, I'm going to do the last one. I'm going to write this first. It would be 3 2 minus 3, and then plus 1 at the end. So all I'm doing is putting the A, K, C, and D into that f at x thing from the top. So set bracket. I'm shifting everything, or translating everything up 1 unit. So up would be up and down would affect y coordinates. So I'm going to add 1 to each of the y coordinates. 5 and 2 and 4. 3 and 1. 4 and 49. 5 and 193. Okay, so you just pick it off piece by piece. Does it affect x? Does it affect y? Think about what's happening, and it really does help you figure out what's going on to each of the points. I hope this is helpful. Don't hesitate to email me if you have any questions. These are the ones you should try on page 49. Okay, good luck.